Hello, welcome to another briefing. So I do not have a tripod yet, but I will get to it eventually, as most things go. Um, so apologies for any kind of wobbly camera or such. But today I wanted to start out by actually showing you the satellite image. And what I wanted to point out here on this satellite image of the Northeast Pacific sector, unfortunately it does cut off around the Portland area, so apologies to folks further north, but I do tend to focus mostly on the Bay Area and California anyways, since that is where I'm based, but I will occasionally, to the best that I can, include other areas as well. So we're gonna look at the animation here, the last 48 hours or so. I think it's a little less than that, but see, if I scroll through this here, you can see this kind of rotation. So you notice there's a bit of a rotation on the right under these clouds. You see these storm systems way out in the Pacific. Let me see, it's kind of hard to show. Okay, I think the resolution's a little better now, so you can see the state of California here where my mouse is to the right here. And then if you go, if you look out towards the Pacific, you see storms are out there, but they are getting deflected to the north as they bump into this big wall of dry air that is influenced by this big high pressure system. And you can see as they start to tilt north as they get closer to the coast. And I'm going to show you the computer model projection for the European model last night, what is projecting for the next few days, and you can clearly see this is about the 10 a.m. time frame this morning, which is at about 30 minutes. You see this 585 decameter high pressure ridge with above average heights. This is looking at pressure height anomaly at 18,000 feet. So you can see this big high pressure system, basically a lot of warm, dry air that's blocking the storms that are trying to come in here. And you put this into motion, this projection for the next few days, you see this sharp ridge of high pressure just start to dominate the weather across pretty much the entire West Coast, well into the Pacific Northwest and British Columbia as well. And you see kind of a trough digging down here over Southern California. Now, we're going to go to a different map here, show you precipitation. And you see how there's very little of it over these next few days that the high pressure is in control. See, these storms are getting deflected to the north, as I mentioned. So now, let's go back to the other map. You see this ridge kind of tilt and push into the Pacific Northwest, and then you see a couple systems sneak by. There's this one system, this trough. It's an inside slider, so it does not have much moisture at all with it, but it sneaks in the 6th through the 7th, and I'll just show you that precipitation map. You can see there's not a lot of moisture with this. There's some light snow for parts of Nevada, maybe, parts of Utah, Idaho, Intermountain West here, but really not much to speak of. Very light snowfall for them. And nothing much for the Sierra or any parts of California at all. It's just too dry of a system. What it will do is it'll bring some wind to Southern California, and it'll bring some colder air as well. Not significantly cold, but chilly. It'll bring some winds. I'll show you that now on the high resolution rapid refresh model. And see our latest. Okay, so this model goes out till 4 a.m. Tuesday, but you can see these winds starting to pick up here over Nevada and the Sierra Nevada here. And that's reflective of pressure heights. Let me see, I want to show you a different map for that. So you look at the mean sea level pressure and the pressure, sorry, that's due to the pressure gradient. See, I'm starting to get a little bobbled here, but the surface pressure gradient, which is the difference in between this, what the pressure at the surface is in different areas, like say Winnemucca, Nevada to San Francisco. When you see a really tight pressure gradient, there is where you're going to get more wind. The tighter the gradient, the more wind there is, and you see this gradient sets up. And there's another high pressure center offshore of Northern California, so it looks like maybe the gradient won't be as tight as it could be. It'll get windy, but not extremely windy. It'll get very windy along the Central Sierra and the Southern California. If I put that, see, look at that. Look at that. Look at those winds. Southern Nevada and Southern California. Looks like getting the most wind. See, there's some wind in the Northern California here too, as we look through the day on Tuesday on the European model. I'm looking at a wider view of things here. Actually, I'll put this on the high resolution rapid refresh too, because that's a better, high resolution is always like the best to look at really for this kind of stuff. So let's go into miles per hour wind speed. So yeah, but then see, it just doesn't go as far out. I'll put this in the NAM model, it goes a little further out. But look at that, you see, I mean, look at some of these wind values over the Sierra Nevada, like could be sustained winds over 50 miles per hour. That does a better, these high resolution models can do a better job at picking up on those sometimes, because you look at the same time frame on the European model, 18Z on Tuesday, and it's not showing that. See, the NAM, the high resolution, shows those, like, it does a better job of picking up the terrain features that can cause things like wind funneling and even wind shadowing, and so some areas get very little wind and others get just blasted with wind as it like funnels through canyons and such. And that's very well represented here through the Central Sierra on the NAM, and you do see, as I was mentioning, some wind in the Bay Area too, just not as much as we're thinking that Southern California is going to get. And so that's really, I mean, those are the main things going on out west for the next 10 days or so. What we're going to be talking about is pretty much wind. Unfortunately, there's really not much precipitation that's showing up in the model runs for now. I can even show you. You see, there's really not much all the way out to the 20th on the Euro model, and even the GFS model. Like, if you look at total accumulation projected for that entire period, almost like Southern California, still nothing at all. Middle of January, even Northern and Central California, very little. And if you look at what the anomalies would be looking like for the 16-day anomaly, look at that. Look at this dry anomaly. Even the Pacific Northwest, the Seattle area, could be way drier than normal for that 16-day period. The GFS and the Euro. Let's see, the Euro does 15 days here. Well, it's not done running yet. Or it is. Okay, so yeah, still same tongue of dry anomaly here. That's not very good at all. That's not what you want to see in the middle of winter. Now I just wanted to touch a little bit on possibility. This is still very far out, so take this with a grain of salt for sure, but the possibility of maybe some Arctic air pushing into parts of the West Coast as we would go way out here into the 18th, 19th, 20th. And on the European, let's see if the GFS is showing that too. The GFS shows a bit potentially as well. It's just a different setup. So let me look at 5,000 foot temperatures here. let's look at the last full run. Towards the end of the run. See this? Yeah, there's some, just looking at anomalies. I mean, there's a little push there. Let's see what the GFS has. Yeah, there's something. It's not really significant, but there's a possibility of something. And the reason that would happen would be because we would have this very sharp ridge of high pressure over Alaska, going into the Arctic. This is the Arctic Circle here, that this very strong ridge of high pressure, 564 decameter high in the Arctic Circle in January. That is the kind of stuff that unleashes the cold, the frigid Arctic air that sits over the Arctic, often referred to as the polar vortex. It shifts pieces of that cold air to the south. That cold air that's almost always concentrated up here gets displaced when you have a big ridge of high pressure and you have a lot of warming over the Arctic areas. That's when you get these Arctic blasts into parts of the United States, and it depends exactly where those set up, but like through in the East Coast here, we have a bit of an Arctic blast for this next week or so, and you see that's caused by a big ridge, but it's up into the Arctic Circle over by Greenland, and that's causing this forcing of cold air down into the east. Our potential Arctic blast out west, which might happen around the 18th to 20th time frame, would be caused by a ridge out over Alaska. So it's a bit different. And there's, yeah, I think I'm going to keep this briefing at, we're already at 12 minutes, so I'm going to do a separate briefing probably for what's going on the East Coast, because there's a lot going on there in terms of snowstorms and ice storms and such, but I think that's going to have to be a different briefing. I hope you enjoyed this video. I hope you were able to get something out of it. Thank you for watching, and I'll see you next time.